Here's a lesson for Note 6-4, graphing linear inequalities. So in the previous lesson, we learned how to graph inequalities with one variable, such as like x is less than 4. And we talked about whether to use a solid dot, an open dot, and which direction to draw the line. So in this lesson, we're going to be graphing lines, but then they're going to be inequalities. So we're going to have to shade a particular region to represent the solution. So we use a solid line when we have the symbol less than or equal to or greater than or equal to. So when we have that line underneath, we use a solid line that would include all the points on the line. And then we would use the dash line, which would look like this, if we have a less than or a greater than symbol. And this means it does not include the points on the line. To determine which side of the line to shade, what you're going to do is you're going to pick a test point. So step one, you're going to pick a test point on either side of the line. And usually the easiest point to pick, as long as it is not on the line, is the origin. Just because 0, 0 is the easiest point to plug in. Then you're going to plug it in and evaluate the inequality. You're either going to have a true or false statement. So if it's true, you're going to shade the side the point is on, because that point is basically a representative of all the points on that line. If that point is a solution, that means all the points on that side would be a solution. If the statement is false, you're going to shade the other side. So we'll look at an example on the next slide. All right, so let's look at number 1. So this says y is less than 1/3 x plus 1. So first thing we're going to do is we're going to graph this line. So remember, we begin at the y-intercept, so I'm going to put a dot at the y-intercept. And then my slope tells me I'm going to go up 1, right 3. And I'm going to continue that pattern. For this line, I'm going to use a dashed line, since it is just a less than symbol, meaning we're not going to include any of the points on the line. So now we're going to decide which side to shade. So we need to know if all the points above the line are solutions or all the points below the line are solutions. So in this case, what we're going to do is we're going to pick a test point, which I'm going to choose 0, 0. Okay. And we're going to plug it in. So when I plug in 0, 0, it's going to be 0 is less than 1/3 times 0 plus 1. Well, we know that 1/3 times 0 is just 0. So this is just 0 plus 1. So it's going to be 0 is less than 1. So we have to decide if that's true or false. Well, 0 is less than 1, so that means it's true. And since it's true, we're going to shade that side of the line. Okay, this basically means that I can pick any point on this side of the line, and it would make that statement true. So all of these points below the line are considered solutions. So just to make sure that we understand, I can pick any other point on here. So say I pick this point right here, which is 3, 1. And I can plug that in, and it should be a true statement. So it's going to be 1 is less than 1/3 times 3. Or sorry, that's 5, 1. 1/3 times 5 plus 1. That's 1 is less than 5/3 plus 1. Well, I know that has to be true since anything plus 1 is going to be greater than 1. So that's true. So that checks out. That means that I did shade the correct side. So think of the test point that you plug in is basically a representative for that entire side. If it's false when you plug it in, then we know that the other side is a solution. If it's true when you plug it in, that means that the side that that point was on is a solution. All right, let's look at another example. So number 2, first thing I'm going to do is I'm going to graph my line. So my y-intercept is 1. and my slope is 5 over 3. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 3. And I'm going to go in the same direction down. This has a line underneath, which means I'm going to use a solid line, which means all the points on that line would be included. And now we're going to pick a test point. And like I said, as long as 0, 0 is not on the line, that's going to be the easiest point to pick. So there's my point, so we're going to plug it in. So it's going to be 0 is greater than or equal to 5 over 3 times 0 plus 1. The other reason why 0 is a good number to pick is because and you multiply anything times 0 at 0. So if you do have a fraction slope, you know that anything times 0 times that is just going to 0 out. So when we simplify this becomes 0 is greater than or equal to 1. That statement is false, which means this point is not a solution, which tells me that all the points on the other side are the solutions. So again, just to check, we could pick any point on here. Let's pick the point -3, 1. When we plug that in, it should be true. So it would be 1 is greater than or equal to 5 over 3 times -3 plus 1. So 5 over 3 times -3, that's going to be -5 plus 1. So it's going to be 1 is greater than -4. That's true, which does check out because we know that that is the shaded side. So just to get a little extra practice determining if points are solutions, because remember, you don't have to choose the point 0, 0, but that is the easiest point, but you should be able to plug in any point to determine if it's a solution or not. So first we're going to plug in, we need to make sure that we know that the first number gets plugged in for x and the second number gets plugged in for y. So the first point I'm going to plug in is 1, 2. So plugging it into my inequality, it's going to be 2 is less than -3 times 1 plus 4. So that's going to be 2 is less than -3 plus 4, which is 1. So 2 is less than 1, that's false. So this is not a solution. Now I'm going to plug in -3, 4. So it's going to be 4 is less than -3 times -3 plus 4. 4 is less than 9 plus 4. 4 is less than 13. That is true. So that means this is a solution. Now we're going to plug in -4, -5. So -4, -5. So it's going to be -5 is less than -3 times -4 plus 4. So that's 12 plus 4, which is 16. -5 is less than 16. So yes, that is a solution because that is true. Lastly, 2, -1. -1 is less than -3 times 2 plus 4. So that's -1 is less than -1. That is false. So that point is going to be directly on the line, actually. So that is not a solution. So if we were to graph this inequality here, the points that would be shaded is a side that contains the point -3, 4 and -4, 5. The unshaded side would contain the other 2 points.